Hello, Tony Candela here with CE Auto Electric Supply. Today I'd like to talk to you about our charging system upgrade kits. A charging system upgrade kit is designed to facilitate the installation of any high output alternator, which is any alternator that's capable of making 100 amps or greater output. Let's show you what our kits consist of. Shown here is our 4-gauge charging system upgrade kit, suitable for alternators of up to 150 amps of output. Included, you get a 4-gauge charge lead with a rubber boot to insulate the lead on the alternator. You get a 4-gauge ground cable to go from the battery negative to the frame. You get a 4-gauge ground cable to go from the alternator case or mounting bracket to the frame. And we include grade 5 hardware to make connections to the frame and to the case of the alternator very simple. You also get an 8-gauge ground wire. This is designed to be cut into 2 different cables. It has an eyelet on each end. One's typically connected from the battery negative to the inner fender, the other from the battery negative to the core support. We include a pair of our very high current, very flexible battery clamps designed to accommodate very large gauge wires. So this makes this installation a snap. You get 2 of those battery clamps, and each clamp comes with an integral plastic cover that's designed to snap onto the clamp to insulate it and give it a nice finished look. Finally, you get a set of cable ties so that you can tie up all of your work and make it look nice and neat. Shown here is our 2-gauge charging system upgrade kit, suitable for alternators making up to 225 amps of output. The contents of the kit is identical to the 4-gauge kit with the exception of these 3 cables, all of which are now 2-gauge. Shown here is our 1/0 gauge charging system upgrade kit, suitable for alternators making up to 300 amps of total output. Again, the only change being these 3 cables, which are now 1/0. This should give you some perspective. This is 10-gauge. It was commonly used by the OEMs when alternators made a maximum output of about 50 amps. This is 8-gauge. This is what's commonly sold in the aftermarket as an upgraded charge lead for an alternator, although it's only suitable for alternators making, say, around 90 amps of output. This is 4-gauge. This is good for alternators making up to 150 amps of output, which are all too common nowadays. This is 2-gauge, good for alternators making up to 225 amps of output. And this is 1/0, good for alternators making up to 300 amps of output. Now, what size cable do you think I see the most often when I go nosing around under hoods at the cruise? You got it. 10-gauge. So now that you know all about our kits, we're going to do the installation of one of our 4-gauge charging system upgrade kits on a 1970 Chevelle that has a 454 big block Chevy. The owner of this vehicle recently purchased an alternator from Summit Racing that makes 100 amps output. So this kit should be perfect. We're going to do before and after testing, and we're going to show you some of the specialized tools we're going to use to do that. On the left is a Fluke 87 digital multimeter. We're going to use it to monitor voltage when we do our state of health measurements before and after. On the right is a Model 88 Series 5. We're going to use it in conjunction with the Fluke i410 current clamp to monitor current when we're doing our state of health measurements before and after. This is a Snap-on MT3750 AVR charging system analyzer. I use this analyzer a lot. The reason I like it is because it has an integrated 500 amp carbon pile load, so you can easily load test an alternator of nearly any size. This machine is incredibly accurate, and I have used the Fluke meters I just showed you to verify its accuracy for both voltage and current, and it's within about 1%. We've got a little over 60 amps of current at idle, and we're maintaining right around 13 volts. That's with the headlights on, electric fan on. Keep the high beams on. We're going to turn the high beams on here, see if that changes anything. little bit. So now we're a little over 60 amps with electric fan on. But notice the alternator voltage is significantly below 14. It's 12.8. Get a closer shot of that. Alright, let's see if we can improve on this. Alright, so now we're going to load test the alternator, and we've turned off all the accessories. We're just going to use this as the load only, and we're going to load it down to where voltage here gets down to 12.0 volts and take a reading. So let's do it. Okay, now we've done our upgrade, and without changing anything other than just the upgrade, you can see now that the alternator is working quite a bit more efficiently. Notice the battery voltage is well above 13, and that at idle, with our accessories now, we're able to draw on the order of about 70 amps of current, which is significantly more than we were able to do so before. So now let's load test it. Okay, now that we've got the upgrade completed, let's load test the alternator again, and we'll see if we have a pretty substantial improvement in output current at idle. You can see so far with just the increase in charge lead size and correctly grounding the charging system, we've got a substantial increase in operating voltage and output current from the alternator at idle. So let's give her a shot. At about 83 amps at just a hair under 12 volts, and if you notice, the engine RPM in the background was actually coming down a little bit because the alternator is making substantially more output. So I would say that's a pretty healthy increase. So job well done. Simple upgrade, and the results speak for themselves. So now that the installation is complete, let's evaluate the results we obtained. When we first started the work, we measured the performance of the alternator with the existing 10-gauge charge lead. We were able to get 62 amps of output at idle out of the alternator, but only at 12.8 volts DC with all of the accessories on. Not very good. After the installation, we were able to increase the output current at idle with all the accessories on to 70 amps. We were able to also do that at a much higher output voltage at 13.65 volts. Now, when we talk about the effectiveness of this, it's important to understand that voltage times current is wattage. So let's look at the difference in wattage that we obtained before and after. Before, 62 amps times 12.8 volts is 793.6 watts. After, 70 amps times 13.6 volts, that's 955.5 watts. We saw a 6% increase in voltage. We saw a 13% increase in current. But that works out to a 20% increase in wattage. And wattage is a measure of work. So devices like electric fuel pumps, electric water pumps, headlights, etc. respond to both current and voltage. So basically we're talking about a 20% difference in output wattage. That's a big deal. Now before, when we load tested the alternator, we were only able to get 70 amps out of it at idle. You may have noticed that the reading on the analyzer spiked 82 amps for a brief second, but that was simply because the owner got the RPM a little too high. So when we got it back down to normal, we were able to lock in and obtain a reading. On the second attempt, after we installed the kit, we were able to get 83 amps at idle. And at that point, you'll notice the vehicle idle actually dips a little bit. So if anything, we might have had a little more current output available there. So there you have it. We had an 18.5% increase in output current available at idle. Pretty big difference. So for this meager investment, this is one sure way to get the most bang for the buck out of your charging system and ensure all of your electronics and electric accessories are working at their optimum conditions.